Okay, thermodynamics part 4, where we're talking about delta G and redox, because it's very important just to touch on this, even if it's ever so briefly. Okay, so we're going to define the standard reduction potential, E naught, and of course the biochemical standard reduction potential, E naught prime. We're also going to calculate the free energy changes in redox reactions. So I'm going to give you that formula. Okay, so E naught, as you can see the naught, this means that this occurs at the standard chemistry conditions. So this is at 1 atmosphere, 25 degrees Celsius, and everything is at a concentration of 1 molar. Okay, so this is really the standard, this E would typically mean the reduction potential. And with that little naught, that means it's standard. Okay, so the reduction potential, you can kind of think of it like pKa tells you how easily a proton will be lost. The reduction potential will tell you how easily an electron will be lost. Because remember, the losing of electrons is oxidation, but it will cause reduction. So this is the potential of a substance to cause reduction, the loss of an electron. Okay. And so this typically involves metals, and we can use the standard hydrogen cell. Reference cell in order to calculate the standard reduction potential. So this involves bubbling in hydrogen gas at 1 atmosphere. We have a standard hydrogen electrode, a voltameter, salt bridge, 2 half reaction cells, anode, cathode, all that stuff. Okay, but at the end of the day, this is a constant because these are constant, and you can look this up in a textbook. But because of this would mean that it's not at pH 7, so biochemists have their own standard reduction potential at pH 7. So this is the same, this is still at 1 atmosphere, 25 degrees Celsius, and then also at pH 7, but everything else is at concentration of 1 molar. But we've added in the pH 7 bit. Okay, so those are those two ideas, and it's the same idea. It's how easily that an electron will be lost. Okay, and so this relates to delta G. Delta G naught prime equals the opposite of Faraday's constant, the number of moles times Faraday's constant times the change in the standard reduction potential, which is the same as saying NF, the standard biochemistry electron potential of the acceptor minus the standard biochemistry electron potential of the electron donor. Because remember, this is moving, the electron is moving from one to another. So this is like substrate product. So products minus substrate is going to give us this value right here. So this is going to be the formula that you need, and this is one way to calculate the standard biochemical free energy.